Bismillahirrahmanirrahim. In the name of Allah, the most merciful and most beneficial. Me, Huzefa Khalid, a student of Comsat Institute of Information Technology, and my group members, Afaq Ashraf and Sadakat Abbas, are giving a presentation on synthetic fiber, which was assigned to us by our chemistry Ma'am Zahra Khan. First of all, I would like to tell you what are fibers actually. Fibers are close class of hair-like materials that are continuous filament or are in discrete elongated pieces, similar to pieces of thread. There are three types of fibers: natural fiber, cellulose fiber, and synthetic fibers. Natural fibers are made from plant, animal, and minerals, and they can be classified according to their origin, for example, vegetable fibers, animal fibers, and mineral fibers. What are synthetic fibers? Synthetic fibers are the result of extensive research by scientists to improve on naturally occurring animals and plant fibers. In general, synthetic fibers are created by forcing, usually through extrusion. Before synthetic fibers were developed, artificially manufactured fibers were made from cellulose, which comes from plants. These fibers are called cellulose fibers. Synthetic fibers are made from synthesized polymers or small molecules. The compounds that are used to make these fibers come from raw materials, such as petroleum-based chemicals or petrochemicals. Synthetic fibers generally have the same common properties. Generally, they are known for being heat-sensitive, resistant to most chemicals, resistant to insect, fungi, and root, low moisture absorbency, lactostatic, flame-resistant, density or specific gravity, peeling. There are methods of manufacturing synthetic fibers, but the most common is the melt spinning process. It involves heating the fiber until it begins to melt. Then you must draw out the melt with tweezers as quickly as possible. The next step would be to draw the molecules by aligning them in parallel arrangement, bring the fiber closer together and allow them to crystallize and orient. Lastly is heat setting. This utilizes heat to permeate the shape of the fibers made from the heat-sensitive fibers. Now, our next question is how many types of synthetic fibers are? The first artificial fiber, known as artificial silk, became known as viscose around 1894 and finally rayon in 1924. A similar product, known as cellulose acetate, was discovered in 1865. Rayon and acetate are both artificial fibers, but not truly synthetic, being made from wood, although these artificial fibers were discovered in the mid-19th century. Successful modern manufacture began much later. Nylon, the first synthetic fiber, made its debut in the United States as a replacement for silk. Its novel use as a material for women's stockings overshadowed more practical uses, such as replacement for the silk in the parachutes and other military uses. Common synthetic fibers includes nylon, monoacrylic, olefin, acrylic, polyester, and carbon fibers. The first and common type of synthetic fibers is nylon. Nylon is generic designation for a family of synthetic polymers known generically as polyamide. What is nylon actually? Nylon is a thermoplastic, silky material first used commercially in a nylon bristled toothbrush, followed more famously by women's stocking. It is made of repeating units linked by amide bonds and is frequently referred to as polyamide. Nylon was the first commercially successful synthetic polymer. There are two common methods of making nylon for fiber applications. In one approach, molecules with an acid group on each end are reacted with molecules containing amine group on each end. The resulting nylon is named on the basis of the number of carbon atoms separating the two acid groups and two amines. These are formed into monomers of intermediate molecular weight, which are then heated to form long polymers. The general reaction of nylon is given as following. The general characteristic features of nylon 66 includes they are more compact molecular structure, they are having better weathering properties, better sunlight resistance. Nylons are softer hand, they are having higher melting points around 256 degrees centigrade or 492.8 degree Fahrenheit. They are having superior color fastness. Excellent abrasion resistance are also included in the characteristics of the nylon. Nylon has the ability to be very lustrous, semi-lustrous, or dull. They are having high elongation. They are giving the paved way for easing care garments. They do not burn, they melt instead of burning. Having good specific strength includes in the nylon 66. They are transparent to infrared light. On the other hand, nylon 6 is easy to dye, more rapidly fades. It has a higher impact resistance, a more rapid moisture absorption, greater elasticity, and elastic recovery.
Nylon fibers are used in many applications, including fabrics, bridal veils, carpets, musical strings, and robes. Solid nylon is used for mechanical parts such as machine screws, gears, and other low to medium stress components previously cast in metals. Engineering grade nylon is processed by extrusion casting and injection molding. Solid nylon is used in hair combs. Type 66 nylon 101 is the most common commercial grade of nylon, and nylon 6 is the most common commercial grade of molded nylon for use in tools such as the spudgers. Nylon is available in glass-filled variants which increases structural and impact strength and rigidity, and molybdenum sulfide filled variants which increase in lubricity. The next type of synthetic fibers is modacrylic. Modacrylic fibers are modified acrylic fibers made from acrylonitriles, but larger amounts of other polymers are added to make the copolymer. A modacrylic is a synthetic copolymer. Modacrylics are soft, strong, resilient, and dimensionally stable. They can be easily dyed, show good press and shape retention, and are quick to dry. They have outstanding resistance to chemicals and solvents, and are not attacked by moths or mildew, and are non-allergenic. Among their uses are in apparel things for like outerwear, paint roller covers, scatter rugs, carpets, and for clothings, and as hair in wigs. A modacrylic has properties that are similar to an acrylic. However, modacrylics are flame retardant and do not combust. The fibers are difficult to ignite and will self-extinguish. In addition to a modacrylic flame retardant properties, it has a relatively high durability that is comparable to wool. Modacrylic fibers have a moderate resistance to abrasion and a very low density. The basic uses of modacrylics are as follows. Modacrylics are used primarily in applications where environmental resistance or flame retardancy is necessary or required. Modacrylics have the ability to combine flame retardancy with a relatively low density, meaning protective gear is not uncomfortably heavy. That shirts and trousers worn by electrical linemen. The combination of flame retardancy and low density is also useful in furnishing draperies and outdoor fabrics. Modacrylics are also commonly used in fake fur fabrics, topes, wigs, and fleeces. By mixing the various forms of fibers, it is easy to create a realistic fur look. The heat sensitivity of modacrylic also allows wigs and hairpieces to be curled and heat styled without damages. Modacrylics are also used in fleeces, knit pile fabric, backings, and non-woven fabrics. Some other uses of modacrylic include paints, rollers, industrial fabrics, stuffed toys, and filters. Olefin fibers is another type of synthetic fibers. Olefin fiber is a synthetic fiber made from a polyolefin, such as polypropylene or polyethylene. Olefin fibers can be multi or monofilament and staple to or film yarns. The fibers are colorless and round in cross section. This cross section can be modified for different end uses. The physical characteristics are a waxy feel and colorless. Actually, there are two types of polymers that can be used in olefin fibers. The first, polyethylene, is a simple linear structure with repeating units. These fibers are used mainly for ropes, twins, and utility fabrics. The second type, polypropylene, is a three-dimensional structure with a backbone of carbon atoms. Methyl groups protrude from this backbone. Stereoselective polymerization orders these methyl groups to the same spatial placement. This creates a crystalline polypropylene polymer. The fiber made with this polymer can be used in apparel, furnishing, and industrial products. Including some uses of olefins are apparel, sports and activewears, sock thermal underwears, lining fabrics. In home furnishing, olefins can be used by itself or in blends for indoor and outdoor carpets, carpet tiles, and carpet backings. The fibers can also be used in upholstery, draperies, wall covering, slip covers, and floor coverings. In automotives, olefin can be used for interior fabrics, sun visors, armrests, door and side panels, trunk parasol shelves, and resin replacement as binder fibers is also included in automotive use. On industrial scale, in an industrial setting, olefin creates carpets, ropes, geotextiles that are in contact with the soil, filter fabrics, bagging, concrete reinforcement, and heat-soluble paper. Acrylic fibers. Acrylic fibers are those synthetic fibers made from a polymer, polyacrylonitrile, with an average molecular weight of about 1 lakh to about 1900 monomers units to be called acrylic. In the US, the polymer must contain at least 85% acrylonitrile monomers. Typical comonomers are vinyl acetate or methyl acrylate. All acrylics are constructed from petroleum distillates that are reacted to acrylic acid. This acid is reacted with alcohol in order for a moment to be formed. Polymethyl methacrylate is the most common form of acrylic that is a polymerized form of methyl methacrylate. When it is catalyzed with organic peroxide, it will be separated the double bond in methyl methacrylate molecule and it will join with another monomer which will form the polymer. Now coming towards the uses of acrylic. Acrylic is lightweight, soft and warm with a wool-like feel. It can also be made to mimic other fibers such as cotton when spun or short staple equipment. Some acrylic is extruded in colored or pigmented form. Other is extruded in acro, otherwise known as natural, raw white or undyed. Pigmented fibers has highest light fastness. Its fibers are very resilient compared to both other synthetic and natural fibers. Some acrylic is used in clothing as a less expensive alternative to cashmeres. Due to the similar feeling of the material, some acrylic fabrics may fuzz or peel easily. The other fibers and fabrics are designed to minimize peeling. Acrylic takes color well, is washable, and is generally hypoallergenic. And uses includes socks, hats, gloves, scarves, sweaters, home furnishing fabrics, and awning. Acrylic is resistant to moths, oil, chemicals, and is very resistant. An important type of synthetic fiber is polyester. Polyester is a category of polymer which contains the ester functional group in their main chain. Although there are many polyesters, the term polyester as a specific material most commonly refers to polyethylene terephthalate. Polyesters include naturally occurring chemicals such as in the keratin of plant cuticles, as well as synthetic through step growth polymerization such as polycarbonate and polybutyrate. Polyesters are thermoplastics may change shape after the application of heat. While combustible at high temperature, polyesters tend to shrink away from flame and self-extinguish upon ignition. Polyester fibers have high tenacity and E modulus as well as low water absorption and minimum shrinkage in comparison with other industrial fibers. Unsaturated polyesters are thermosetting resins. They are used as casting materials, fiberglass, laminating resins, and non-metallic autobody filters. Fiberglass reinforced unsaturated polyesters find wide application in bodies of yachts and as body parts of cars. Some uses of polyesters includes fabric balls knitted from polyester thread or yarn are used extensively in apparel and home furnishings, from shirts and pants to jackets and hairs, bed sheets, blankets, upholstered furniture, and computer mouse mat. Industrial polyester fibers, yarns, and ropes are used in tire reinforcement, fabrics for conveyor belts, safety belts, coated fabrics, and plastic reinforcement with high energy absorption. Polyester fiber is used as cushioning and insulating materials in pillows, comforters, and upholstery padding. Polyesters are also used to make bottles, film, tarpaulin, cannons, liquid crystal displays, holograms, filters, dielectric film for capacitors, film insulation for wire, and insulating tapes. Polyesters are widely used as a finish on high-quality wood products such as guitars, pianos, and vehicles. The most important and extensively used synthetic fiber is carbon fiber. Carbon fiber reinforced polymer or carbon fiber reinforced plastic, CFRP or CRP, or often simply we can call it carbon fiber, is a very strong and light fiber reinforced polymer which contains carbon fibers. The polymer is most often epoxy, but other polymers such as polyester, vinyl ester, or nylon are sometimes used. The composite may contain other fibers such as Kevlar, aluminium, or glass fiber, as well as carbon fibers. The strongest and most expensive of these additives, carbon nanotubes, are contained in some primarily polymer baseball bats, car parts, and even golf clubs, very economically viable. As there are a lot of uses of carbon fibers, although it is very relatively expensive, it has many applications in aerospace and automotive fields, such as Formula One. The compound is also used in sailboats, modern bicycle, and motorcycles, where its high strength to weight ratio and good rigidity is of importance. Improved manufacturing techniques are reducing the cost and time to manufacture, making it increasingly common in small consumer goods as well, such as laptops, tripods, fishing rods, paintball equipment, archery equipment, tent poles, racket frames, string instrument bodies, drum shells, golf clubs, helmet used as a paragliding accessory, and pole billiards. This is all about synthetic fibers. Thank you very much.